In this video, let's look at a small, efficient thinking or reasoning visual language model. This is Kimi VL A3B thinking from Moonshot AI. So this is an efficient open source mixture of experts vision language model that offers advanced multimodal reasoning, long context understanding and strong agent capabilities, all the while activating only 2.8 billion parameters in its language decoder. Okay. So this model is comparable to GPT-4o Mini, Qwen 2.5 EL 7 billion, Gemma 3 12 billion, while surpassing GPT-4o in several specialized domains. Now, Kimi VL thinking is developed through long chain of thought, supervised fine-tuning and reinforcement learning. Right, so this model they say is setting a new standard for efficient yet capable multimodal thinking models. I had made a previous video on Kimi VL Instruct. So you can check out that video for more architecture details of this particular model. So let's go to the Colab notebook. So this model requires 30 GB of memory to run. So you need an A100. So this is a paid Colab instance. Okay. So first thing which we need to do is that we need to install TickToken blob file. So once these libraries are installed, you can instantiate the model like this. You can import the model from transformers basically. Right, the model path is this. Model is equal to, you can load the model. So once the model is loaded, it takes close to 30 GB of your GPU VRAM. So then you can now try out your visual language task. So the first task which I am going to give is that I am going to give the Bangalore metro map and I want to navigate from Peenya to Whitefield. So basically there is an interchange at Kempegowda station which is Majestic. So this is the first task, thinking task, which I am going to give. So this is my image path. I've uploaded the images over here in the Colab notebook. And here is the messages in the text prompt which says, how do I go from Peenya to Whitefield? Think step by step, inspect image carefully, give only the final answer. Okay. You apply this chat template over here after processing. Basically on the text, you apply this chat template on the messages and you process the input. The image is given over here, the image path. You give it to the processor, you get your inputs, you give it to the model to generate outputs. Okay, so it says starts with the think token because this is reasoning model. So here it says first I need to go, it does all these thoughts and finally it gives the answer like, board the green line at Peenya, travel north, alight at Kempegowda road station. I don't know where road is coming from, it is Kempegowda station. And then transfer to the blue line. Take it southbound, alight at Whitefield, final destination. So, which is actually not the blue line, but it's actually the purple line over here. I don't know why it goes to the blue line over here. Okay. Green line, Kempegowda, why I don't know, it says it has this thing. Okay. So then I cleared the memory because I want to run further experiments. I gave the complex Delhi metro map and I said go from this location, Tekri Kalan to Old Faridabad Road. So this is complex, it needs to change over here at Kirtinagar and Mandi House and then go. Just to test the complexity, whether it works on complex images. So here it kind of makes a mess of the whole thing, okay. Identifies this as green line, this as pink line, okay, Tekrikalan. It messes up over here totally. Okay, I tried another thing in the same network, which was Okla station. I want to go from Okla to Dwaraka. So I want to go from Okla is somewhere over here and Dwaraka is over here, right? So I wanted to see how it works out over here, right? So probably you need to go over here, do an interchange over here, do an interchange on the yellow line or do an interchange over here, go over here and take an orange line or something like that. It kind of fails over here also. Take the yellow line from Okla to Dwaraka, right? So this is complex, it's not able to do that. Okay, then I gave a simple problem like this, which is about solving a puzzle. So you have two houses plus 1 is equal to this animal. You have two houses plus animal is equal to 25. Solve for this animal. What is this animal? Which number it is? The answer is actually 13. So here it does it very well. Okay, it takes the first equation, two houses plus 1 is equal to animal. Let each house represent the number 6. So you 2 times 6 plus 1, 12 plus 1 is equal to 13. So the animal is 13. And then it says second equation, when you put it, you get it equal to 25. So the final answer is 13, which is correct. Okay. If 2 houses equal to 12, then the number is 13. Then I tried another example where I gave a medicine, image of a medicine over here. I'll open this in a new tab. Okay, I gave this medicine, which is amoxicillin and potassium clavinate, which is an antibiotic, and I said I'm allergic to penicillin. Reason and say whether I can have this medicine. So it says, yeah, the user is asking if they can take the medicine shown in this image. So it was able to do OCR on this image. It extracts the content, and then it says that amoxicillin is a potential. It is it is related to penicillin. Okay, there is a risk of cross reactivity, so it's better that you don't take this medicine. If amoxicillin alone is sufficient to indicate potential risk, it gives a proper answer over here. So this model may be good for visual language reasoning tasks. You can check it out if it is good for your use cases. It does good OCR for sure, so you can test this particular model for your use cases. See you in another video. I will share the Colab notebook link in the description of the video. I'll also share the model link in the description of the video. Do check out.